Hi, this is the first video in a series I will be calling Mathematical Analysis, and this is for more advanced um, levels, but we will begin by discussing simple terms. So the first one we will be discussing is series. Then the second one is, if I recall, differential calculus. And finally, we will be going into integral calculus. Which I will summarize verbally by saying that so series will be about successions. So series will be about successions. Then what they are, partial sums, just to review some basic ideas. So par sums. Then we got convergence, divergence. Still in series, we have absolute and simple convergence. So then we'll be talking about geometric. Geometric, Mengoli, and alternating series. What else? We'll be talking about convergence criterions. Such as, well, we can begin with, we'll begin with the necessary conditions. So the necessary condition for convergence. Then we'll proceed to D'Alembert's criterion. For determining convergence. Actually, let me conserve some space. Then we'll go on to Cauchy's criterion. For determining convergence or divergence. Then we go on to the more complicated ones, which is the comparison criterion. Then we go for the Dirichlet series. Actually, let me make a quick change of plans here, and we'll be talking about the Dirichlet series together with the other series up here. So after the comparison criterion, we will do the integral criterion. So yeah, we'll do a bunch of criterion. So this whole section will be dedicated to the criteria for determining convergence and divergence of a series. Then this will be dedicated to determining the what type of series the current succession is. Um, and first we will try to revisit some bases relating to what is convergence, divergence, partial sums. Partial sums comes before successions, then successions, and we talk about convergence and divergence. So these are in not very correct order. So first is par sums, and then successions. And then and we'll be amplifying the concept of convergence, and afterwards we'll discuss differential calculus. We will begin differential calculus with functions, right? First we'll explore the functions domain graphically, so it's graphical interpretation. Then we'll go on to the functions. Then we'll go on to the functions continuity, exploring the functions continuity. Then we'll see about partial derivatives. Of that function. It's always in regards to the function. Then we'll see about directional derivatives. So then we'll go more in depth about differentiability. Or correction. Let's trade positions. Let's go and order our study more logically here. Let's begin with differentiability. I'm following a manual, by the way. I'm not sure if I have to specify it. I'll figure that one out later. But this manual, it's been very helpful. And I'm doing this as a means of studying and helping others study. Okay, so directional derivatives. Yeah, so this order I think makes more sense. First talk about differentiability, then partial derivatives and directional derivatives. So I'll try to reorganize the material in this order and make it more sensible for you guys. Then after this, and this is in regards to functions and differential calculus, we'll talk about composite and implicit functions, or better even, we'll have to talk about composite and composite slash implicit functions, and we'll go on to their respective derivatives. Next, we'll see about critical points. Extremities, function extremities. and fixture points. Let's maybe alright, and that's in regards to functions. I think that's all. Oh, and we'll be visiting the Schwartz theorem. Sorry. Let's globulate these very quickly. So all of them, so all of these are encompassed in the functions topic, but we'll be suzzing up. So I think just for sake of making better sections here for organizing our study, I think we should create another subsection here, like a directory, mental directory, let's say, for differentiation. So differentiation, and so these functions will encompass mostly, yeah, everything actually. So all of this will concern functions. Yeah, the entirety of it, except the small trick in the end is more directed at speed and efficiency. so let's see. And then we got a differentiation which encompasses more of these aspects. Partial derivatives, composite / implicit derivatives. Yeah, it does that too. And then fixture points. Well, that's something we can deduce from derivatives, but they're not derivatives in of themselves, so they're just results we get from them. So yeah, okay. So that's part number 2. We have series first, then differential calculus. Let me separate them in a more fashionable style. Whoops. So, go like this. There, perfect. Okay, so and this is dead zone. Okay, so on the third part, so finally, we'll take a look at integral calculus. So and inside integral calculus, we'll be seeing, and this part is the quickest one. Well, let's not be too hasty. We'll basically be looking first at double integrals, and then we'll be seeing triple integrals, but each of them in some depth. So we'll start with double integrals, and we'll see about double integrals. We'll see about and this, so we'll see double integrals and triple integrals, and we'll be covering them in the same manner. So for each of them, we will check geometric interpretation, Then we'll move on to elementary properties. Then we'll be seeing, we'll see how to perform, we'll be learning about switching variables or changing variables or variable switching. And finally, area and volume. So calculus, and geometric interpretation with it, and so on. Okay, so this will go first, and this will go second for each and every one of those. Yeah, so that's our study